It's the hidden beast beneath the hood, the mechanical heart that brings our vehicles to life. With a turn of a key or a push of a button, it roars into action, whisking us across continents, tackling mountains, or simply getting us to work. We rely on it every day, but have you ever stopped to wonder, how is this incredibly complex, precision machine made of hundreds of intricate parts actually built? How does raw metal transform into controlled explosions and roaring power? The creation of a car engine is a testament to human ingenuity, a symphony of precision engineering, advanced robotics, and the tireless dedication of skilled craftspeople. It's a journey from molten rock to a masterpiece of power. Welcome to the Smart Side, the channel where we unravel the ingenious science and hidden processes behind the everyday. Today we're taking you deep inside the factory floor to uncover the remarkable story of how car engines are made, from raw materials to the powerful heart of your vehicle. Every engine's journey begins with its foundational components, the engine block and the cylinder head. These are typically cast from strong, durable materials like cast iron or aluminum, chosen for their ability to withstand immense heat and pressure. Imagine raw metal heated to searing temperatures, then carefully poured into intricate molds. As it cools, it solidifies into the rough, recognizable shapes of the engine's core. But this is just the beginning. These raw castings are then subjected to incredible precision. Massive, automated machines guided by advanced computers take over. Robotic arms armed with specialized cutting tools drill hundreds of holes, mill surfaces to incredibly tight tolerances, often to within the thickness of a human hair. Every cylinder bore, every bolt hole, every mating surface must be absolutely perfect for the engine to function. This meticulous machining transforms a rough hunk of metal into a finely tuned component. Now, let's look at the components that truly make the engine move: the pistons, connecting rods, and crankshaft. These are the unsung heroes of motion. Pistons. These precisely engineered cylinders are built to withstand tremendous forces. Each one is designed to fit perfectly within its cylinder bore, sealed by special piston rings that prevent combustion gases from escaping. Connecting rods. These sturdy metal rods act as the crucial link, connecting each piston to the crankshaft. They are often forged, pounded into shape from solid steel to give them incredible strength. The crankshaft. This is the engine's backbone. It's a heavy, precisely balanced shaft with offset journals. As the pistons move up and down, the connecting rods transfer that linear motion to the crankshaft, which then spins, converting the reciprocating motion of the pistons into the rotational energy that eventually drives your car's wheels. Each one is a marvel of balance, ensuring smooth operation at thousands of revolutions per minute. These components undergo rigorous balancing and inspection to ensure minimal vibration and maximum efficiency once assembled. For the engine to truly come alive, it needs air, fuel, and a spark. This is where the intricate workings of the cylinder head, valves, and camshaft come into play. Valves. These tiny mushroom-shaped components are critical. Each cylinder has intake valves to let air and fuel in, and exhaust valves to let spent gases out. They must open and close with incredible precision, thousands of times a minute. Camshaft. This is the conductor of the engine's orchestra. It's a rotating shaft with precisely shaped lobes or cams. As the camshaft spins, these lobes push down on the valves, opening them at the exact right moment for each part of the engine's cycle. Fuel system. Fuel injectors spray a fine, atomized mist of fuel directly into the cylinders, mixing with air. Spark plugs. And finally, a precisely timed spark ignites this air-fuel mixture, creating a controlled explosion that pushes the piston down, generating power. This complex, synchronized dance of intake, compression, combustion, and exhaust, the four-stroke cycle, is orchestrated by the camshaft, ensuring perfect timing for maximum power and efficiency. Once all these thousands of components are precisely manufactured, the magic of assembly begins. Modern engine factories are a breathtaking fusion of advanced robotics and meticulous human expertise. Heavy engine blocks are moved along automated lines. Robotic arms lift and position massive components with incredible precision, tightening bolts to exact specifications. But it's not all machines. Highly skilled technicians perform intricate tasks, such as installing delicate wiring harnesses, inspecting every connection, and ensuring every single bolt is accounted for. As the engine moves down the line, it slowly takes shape, component by component. After assembly, every single engine undergoes rigorous testing, from leak checks to noise analysis, and finally a full performance test on a dynamometer, where it roars to life, ensuring every horsepower is present and accounted for before it ever leaves the factory. So the next time you turn the key or push the button and your car hums to life, remember the incredible journey that powerful heart beneath the hood has taken. From raw earth metals forged and machined with microscopic precision, to thousands of components choreographed to create controlled explosions, the car engine is truly one of humanity's most remarkable feats of engineering. It's the ingenious masterpiece that powers our modern world, silently serving us with every journey. Were you surprised by the sheer complexity and precision behind your car's engine? What other mechanical marvels or hidden technologies do you want us to unravel on the smart side? Share your thoughts and curious questions in the comments below. If you found this journey enlightening, smash that like button to support more smart content, share it with a friend who loves cars, and make sure to subscribe to the smart side for more mind-blowing discoveries. Stay smart and enjoy the ride.